All right, here we have the triangle inequality, which is a little simpler than the Cauchy-Schwarz inequality. So really, the Cauchy-Schwarz inequality does the heavy lifting here. But what does the triangle inequality says or say? Well, what it says is that if you take the norm of A and you add the norm of B, that's going to be greater than or equal to the norm of A plus B. And again, remember little arrows. And I'll draw a nice picture which shows why this is true in cases that make sense to us. Um, that's actually not how I really wanted to draw this picture, but here we are. Okay, let's say this is A. Let's say this is B. And here is A plus B. Well, what this is saying basically is that in a triangle, if you add the lengths of two sides together, the third side can't be bigger than that length, than that sum of lengths, which makes sense. The best case, or the case where it's equal, is going to be the case where A and B are, for example, pointing in the same direction. So if this is A and this is B, then the norm of A plus B is exactly the same as the norm of A plus the norm of B. So they're the same thing. But yes, so we have this inequality. Now, when we get to dimensions like 4 or 5 or higher, we can't necessarily rely on pictures to help us. So let's show that this is true. And we're going to do that using the dot product. So let's actually square both of these sides. Because these are all positive numbers, we can square it without really changing anything. So what happens when we square? What we're going to do is we're going to start with a plus b squared and show that it's less than a squared plus b squared. So here's what we'll do. We're going to start with a plus b squared, as I said. That's going to end up being the dot product of a plus b and a plus b. Because remember, the norm squared is the dot product of the thing with itself. So we can, since we have the distributive property, we can FOIL just like we would expect to be able to do. So this is going to be a dot a plus, since the dot product is commutative, unlike the cross product, we're going to get 2 times a dot b plus b dot b, which ends up equaling the norm of a squared plus 2a dot b plus the norm of b squared. Okay. So we know from the Cauchy-Schwarz, the absolute value of a dot b is less than or equal to the norm of a times the norm of b. And you might not have thought about this, but you can easily convince yourself it's true that adding absolute value signs will only ever make this thing bigger. Because if it's negative, then it's definitely smaller than whatever this positive is. So what I can say is that this thing is actually less than or equal to the norm of a squared plus 2 times the norm of a times the norm of b plus b squared, which is exactly the norm of a plus the norm of b, all of that squared. And that's exactly what we wanted to show here. So the triangle inequality is true mostly in part to the Cauchy-Schwarz inequality. So since we were able to show the Cauchy-Schwarz inequality, gave us the triangle inequality. Let's go ahead and do like we did with the Cauchy-Schwarz. Let's go ahead and show that it works. So let's use our same vectors because they were fun last time. So show, we'll say demonstrate the triangle inequality for 5, 5, 3, 7, 1, and 0, 3, 0, 4. Oh, this will be slightly less nice. We remember from last time, the norms of these things were 10 and 5. So that's going to be 10 plus 5 is 15. What about when we add them together? Well, the norm of a plus b is going to equal, let's see, we'll have 5 plus 8, or sorry, not plus, 5, 8, 7, and 4, 5. I can do math, really good at math, which is going to be the square root of 25 plus 64 plus 49 plus 25. And let's take some time to think about that. Looks like it's going to be 163. Because I see 25, 25, that adds up to 50. And then we have 49, so that's 99, and 99 plus 64 is 163. And I don't know exactly what 163 is, but I know that 169 is 13 squared. So this is definitely less than 13. So what we saw is that the norm of a plus b, or the norm of a plus the norm of b, is in fact bigger than the norm of a plus b, because 15 is bigger than the square root of 163. So we were able to demonstrate the triangle inequality for those two vectors.